500, where will it be? It is going to be in between 4,000 and 5,000, right? So it will be somewhere here. Now, if you trace it to the graph, if you trace 4,500 to the graph, will it touch the graph? Has it touched the graph? Yes, and since it is touching the graph and still the graph is in a straight line, it means that the 4,500, if you hang a force of 4,500, the spring will still obey Hooke's law. If the spring is not obeying the Hooke's law, you know the expected graph, right? The graph is supposed to curve. But even if you hang a force of 4,500 newtons on this spring, the graph is still a straight line. So since the graph is not bending or curving, it means that the student is true, or what the student said is correct. Even if you hang a force of 4,500 newtons on the spring, because the spring is not bending, it still obeys Hooke's law. Now let's move on to the next question. The C. The spring can be compressed by forces. The spring described by figure 1.1 is compressed by a force F and has an extension of negative 0.025 meters. Determine F. So if you are to determine F, which formula will you use? It is still a spring, so the formula will be Kx. It will not change. So the formula will not change. Since the formula will not change, the only thing that is changing over here is the x. And remember, for Hooke's law, we said that the relationship is between the force or the load and the extension. And the relationship is that they are directly proportional. So since the extension is negative 0.025 meters, it means we should expect a different force from the original values that they gave to us on this thing. Because they said determine F, they would have said use the graph to determine F, but they didn't say use the graph. They just said determine F. So what it means is that we are coming to determine or calculate for F. So we substitute the value of x, and then K, since it is constant, you are going to use the value over there. Please calculate. K is what we've determined already. It's constant, so you don't expect it to change. It is the same spring.